Good afternoon, everybody. This is Mr. Hennon, and I am here to talk about the kinematics in two-dimension projectile motion launched at an angle, time of flight. So in this particular case, we are going to look at how do we actually find how long a projectile is in the air when it's launched at an angle. So I'm going to go back to the same football problem that we did with maximum height. So we're going to have this football kicked at a 40-degree angle, and the football is going to be kicked with an initial speed of 22 meters per second. So this V here is 22 meters per second, and this angle here is going to be 40 degrees. I call it VI, they call it VO in the book, so we're going to try to figure out the time that this football is in the air for. The first thing we've got to do is we've got to take this VI, this 22 meters per second, and this 40 degrees, and we got to split it up into how fast it's moving vertically. So in other words, how fast is the football going straight up? So our VIY, and then how fast it's going horizontally. So our VX, or you call it VIX, if you will. So we talked about this already, that to find VIY, it's going to be VI times the sine of our angle. And Vx is going to be Vi times the cosine of our angle. So plugging in the numbers, 22 sine of 40 degrees. And this is going to be 22 times the cosine of 40 degrees. Now we did this already with the first one, so we should be able to get these answers really quick. Make sure your calculator is in degree mode or you're going to get wrong answers here. Times the sine 40. So this is going to be 14.1413. Kind of keeps going, but that's good enough right now. And then 22 times cosine 40, 16.853 meters per second. So we've got, basically what we're doing is we're splitting that velocity. We've got to put it into horizontal and vertical stuff. We can't do anything with the way it is. Now, we're going to come and actually look at all the vertical stuff. So there's a couple different ways to do this. We know that this number, going back to what we just came up with, is 14.1413. So we've got our VI here. And we always know what G is, so our 9.8. Now there's two things to think of. We can either go from here all the way to here, which is our ultimate goal, or we can do this at half the distance and then end up doubling stuff, because that's one of the things that's kind of nice. I'm going to go ahead and go all the way to here. So there's a couple of things I can actually say about this. One, we know that the football is taking off upward, so an initial vertical velocity is going to hit that. When this football hits over here, it's actually going to be going down with that same velocity. So the V here, the Vy here is going to be the same, but it's just going to be in the negative direction. It's going to be going downward. So I can make my Vf actually be negative of this 14.1413. That's one thing to kind of help us with. The other one is if we assume the football is kicked from the ground, travels through the air, and then lands on the ground, vertically it hasn't moved anywhere. We know it went to this maximum height, but for the y, we can actually put this in as 0, because for the entire motion, it actually came back to its same vertical point. So these two little bits of information we have to actually kind of go after. So what that means is there's actually a couple different ways we can solve this. One idea is we can use the idea of y, say that y is equal to VIY times t minus 1/2 gt squared. And I can plug all my numbers in, and I can solve for time. The other method, since I have VF and VI, is to realize that VFY equals my VIY minus G times T. Now, I tend to go for this one. I kind of like this one because there's no squares. We don't have to kind of worry about that. So that's the one I'm going to actually use. So I'm not going to use my Y here. I'm going to use this as 9.8. This is my negative 14.1413. This is the positive 14.1413. And we don't know what this is. So I plug those in. VFY equals VIY minus GT. Basically, what's going to happen is I'm going to end up subtracting this over to the other side, and I'm going to end up dividing this to get at T. So time is going to be the difference in my velocities over minus G. So I have a negative 14.1413 minus a 14.1413 all over negative 9.8. Now, the top does not cancel. It really just doubles the velocity. So the idea is the velocity is going to go from 14.13 down to 0, and then from 0 back up to 14.13. So it's really like I doubled the number and then divide by 9.8. So I've got this number already saved. I'm basically going to multiply by 2 and then divide by 9.8. And the negatives are going to cancel, so that's nice. So we get a positive time here. And my time would be 2.8. I'll just round it to 3 sig figs. 2.89 seconds. So that's the easiest way to find time. You can use the other one and see what you get. Basically, what you're doing is you're using the fact that the final velocity or the final displacement is 0 because it comes back to that same initial height. We'll do some situations where we have a Y, and we'll actually have to find that and plug that in. But this is the easiest way, I think, to find time. So the last thing I'm going to leave you with is this little sample problem. Let's say a baseball is hit by our batter at a 65-degree angle, so it's kind of a steeper angle at 25 meters per second, assuming the air resistance is negligible and the baseball is hit and lands at the same height. So in other words, let's say it's actually caught by somebody. How long would the baseball be in the air? So I want to leave that for you, and I want you to try to solve for it using the same kind of idea that I just came up with, and see what you can come up with in the little Google form that is going to go with this. Hope you enjoyed this edition of the Henstitute.